Hey guys, welcome. This week we're going to be continuing with Unit 6, which is polynomial functions, and we're going to be starting looking at factoring. And that's actually something you guys did quite a bit in Algebra 1 too. We'll also be learning methods for factoring larger polynomials like cubic equations or quartic equations, things that are much larger than what you may have seen early on. Okay. So why are we factoring? Factoring is actually really helpful, particularly for finding x-intercepts of equations. And if we have it in an equation in standard form, it's hard to find the x-intercepts if we're just plugging in y equals 0. You can use the quadratic formula if you want, but the quadratic formula doesn't work on larger types of polynomials. If we have an equation in factored form, however, we can use what's called the zero product property to solve for x-intercepts. And we'll be learning about solving for intercepts later on this year. So for now, just know that we're going to learn about factoring because it's going to be helpful later on. Okay. So we're going to learn several types of factoring. The first type we're going to learn is just factoring out a greatest common factor. And what that means is pulling out any terms that everything shares to help simplify the equation. And so there's actually several methods of doing this. For some people, it helps to split apart terms into all the things that they multiply to make, and then find all the matches and use those to find the part that you would factor out. I like to do the second method, which is to just divide one step at a time and divide things out. And everything that we're going to divide out, we're going to end up multiplying and combining together in the end. And really all this is a reverse distribution. So we've learned distribution before, which is where you multiply something on the outside of a parentheses through. This is just doing the opposite method of that. So doing a reverse distribution. Okay, so we're going to try a couple of these problems here. And I'm going to stick to method 2 because that is the method that I prefer, but you're more than welcome to do method 1. I'm sure there's lots of videos of it online. Okay, so I'm going to start with this first one here. And what I do is I look for something that I can divide both of those things by that would be the same. So I have 12 and 18. Well, I know that both of those can be divided by 2. Those are both even numbers. That's always a quick thing to look for. If they're even, they can be divided by 2. So I'm going to divide both parts by 2. And so what I'm going to end up with is 12x divided by 2. That's 6x. And then negative 18 divided by 2. That's minus 9. Well, I have to do something with that 2 that I just pulled out. So I just put it in the front here. So now I look and I see, is there anything else in this parentheses that I just made that can be pulled out? Anything else that they can both divide by? Well, 6 and 9 can both be divided by 3. So I'm going to try dividing everything by 3. Oops. All right, so then when I do that, what I'm going to have in the front here is I'm going to have 3 times that 2. And then what I have left in the parentheses here is 6 divided by 3, which is 2x. And then negative 9 divided by 3, which is negative 3. I'm going to simplify this front part. 2 times 3, that makes 6. So I have 6 times 2x minus 3. So now I just want to check my work to make sure that that makes sense. So I'm going to reverse that process. I'm going to do a distribution and see if I get back to my original equation. Six times 2x is 12x, and 6 times minus 3 is minus 18. And that gets us back to our original equation. So that works. So we can just go through and divide by things that we see in there. Sometimes you might be able to see it right away that like, oh, those both can divide by 6 and just do it in one step. But sometimes it might take more steps, and that's okay. For this next one here, I have 7x squared plus 13x. So I look at the 7 and the 13. Well, those are both prime numbers. There's nothing that either of them could be divided by that they would share. 7 can only be divided by 7, and 13 can only be divided by 13. So I don't have any numbers I can pull out. But they both have an x in it. One has an x squared and one has a regular x. So if I divide both of these by x, what I'll end up with is 7x squared divided by x. So that's just pulling out a single x from it. So I'm just left with 7x. And then 13 divided by x. That's pulling out a single x from that. So that's just the 13. So I look, there's nothing else that they can both divide by, 7x and 13. There's nothing else that they both share in common. Just like before the 2x and the minus 3, there was nothing else that those could be divided by. All right, so I just want to do a quick check of my work. Make sure that this makes sense. So if I have x times 7x plus 13, it should get me back to that original equation. So I distribute. X times 7x is 7x squared. X times 13 is 13x. So that checks out. Okay. Going on to ones that are a little bit more challenging here. So down below, I have this 15x to the 4th plus 25x cubed minus 35x squared. So I'm going to go through and see what I can pull out of here. And again, some of you might be able to go through this in one step and just see exactly one thing that can be pulled out that would simplify it completely. But others might need to go through more steps, which is what I'm going to do. So I look and I see that all of these have an x in it. So I'm going to start by dividing everything by x. So I'm left with 15x. And when we divide by an x, that's just going to pull out a single exponent. So it's x to the 4th, so it's x times x times x times x, and a single one got taken out. So now it's x cubed, x times x times x. 25x cubed divided by x, that's the same idea there. So if I have x times x times x, and I divide out a single one, I'm left with x times x, which is x squared. And then negative 35x squared, that's x times x, and I divide out a single x, so I'm just left with a single x on there. Well, now I see these all still have x's in it, so I can do that same kind of step again. So this time I'm going to divide by another x. So on the outside here, I have the x that I'm dividing by now and that original x that I divided by. So these are all just going to reduce by one exponent. That's what happens when we divide by an x. So that's going to be a 15x squared. 25x squared divided by x is going to be a 25x. And negative 35x divided by x is going to be just negative 35. All right, so now I look and I see if there's anything else. Well, pardon me, got like a tickle in my throat. All right, those can all be divided by 5. 15, 25, and negative 35, those all end in 5, so those can all divide by 5. So I'm going to divide each part by 5. So I'm going to divide by 5 on each of those parts. So now on the outside, I'll have 5 times x times x. And on the inside, I'm going to have 15 divided by 5. That's 3. Oops. 25 divided by 5 is 5. And 35 divided by 5 is 7. Got to keep that minus on there. So I'll simplify what I have in front. I have 5 times x, that's 5x squared. And then the inside, again, is that 3x squared plus 5x minus 7. And checking your work should be really easy. Again, it's just going through and doing the distribution. So when I multiply here, 5 times 3 is 15. X squared times x squared. That's 2 x's multiplied times another 2 x's multiplied. That makes a total of 4, so that's x to the 4th. 5 times 5 is 25. And then x squared times x, that's 2 x's getting multiplied, and then another one getting multiplied, so that's a total of x cubed. And then 5 times negative 7 is negative 35, and it will have that x squared on there. So that checks out. That gets us back to our original problem. So it was quite a bit of a longer one that had a lot more steps, is more advanced. But again, it's just really a reverse distribution. So in this last one on here, I go through and I look and I see, is there any x's they all share? Well, 17x squared, that has an x in it. 4x, that has an x in it. But 5 doesn't. So they don't have an x that they can all pull out. So I look at the numbers. 17, that can only be divided by 17. It can be divided by 1, but we really don't count 1. Pulling out a 1 doesn't help anything. 4 can be divided by 4 or 2 and 2. And 5 can be divided by just 5. So, they don't have anything that they can share in terms of numbers either. So in this case, we would say there's no greatest common factor. There's nothing that all those parts can get divided by. All right, so That is factoring using greatest common factor. Next up, we're going to be looking at difference of squares. Okay, so difference of squares is a nice little pattern that shows up sometimes when we're factoring that we can use to simplify quickly. So anytime we have two factors that are exactly the same, but one is a plus and one is a minus, the way that it always works out is that you'll have two middle terms that are exactly the same, but one is a plus and one is a minus. And so those terms will cancel out to make 0. And so you're just left with the first number times itself. And then there's a minus because there's, a plus and a minus. The last number times itself. And so it's a nice little pattern that shows up that makes it quick to factor where we don't have to have box and diamond or anything like that. We can just look at this pattern and use it to solve quickly. So first what we're going to be doing is we're going to go through and look at problems where we're multiplying to look at how that pattern plays out, and then we're going to use that to factor quickly. So first with multiplying, I'm going to move my face slightly. There we go. I'm going to look at this x plus 3, x minus 3. So if I was doing an area model of this problem, if I wasn't using this trick that I'm showing you guys, I would say, okay, I have x times x, that makes x squared. I have x times negative 3, that makes negative 3x. I have x times positive 3, that makes positive 3x. And then I have positive 3 times negative 3, that makes negative 9. So writing that out, that's x squared, and I have a positive 3x, and I have a negative 3x, and then I have a negative 9. So just like what we were seeing in the previous page, we are going to end up having a positive and a negative of the same type of x that will end up canceling out. And so we're just left with x squared minus 9. Now we can also use this pattern that shows up above. So we have nothing in front of the x here. We'll just use that as our a. X times x makes x squared. So we're going to start with x squared. Then 3 times negative 3 is negative 9. So that'll make a negative 9. So this is a nice little pattern that works out, but only when the two factors are like this, where it's a plus and a minus, but everything else is the same in terms of numbers. This doesn't work on situations where the numbers are different in each factor. All right, so we'll look at another one using an area model, and then using that idea also of using the formula that we have above, or the shortcut. So I have 2x times 2x, that makes 4x squared. I have 2x times negative 5. 2 times negative 5 is negative 10. And there's an x on it. 2x times positive 5 is positive 10x. And 5 times negative 5 is negative 25. So that would equal 4x squared plus 10x minus 10x minus 25. So again, we have a situation where there's a positive and a negative of the same term. So we can cancel those out, and we're left with 4x squared minus 25. Now I can also use, again, this pattern or the shortcut that we see above. So 2 times 2, 2 squared, that's going to make 4. So I'm going to end up with a 4x squared. Then for my second term, I have 5 times negative 5. That makes negative 25. So it's a lot quicker to solve these that way once we have this little formula. Or shortcut, or whatever I want to call it. I keep switching up what I'm calling it. Formula, shortcut, trick, cool little thing. I don't know. All right, so now we're going to try it without using a box and diamond. So again, what I'm looking at is the first part times the first part. X times x is x squared. And then it's going to be that last part times the last part. 9 times negative 9 is negative 81. So we just really quickly multiplied those two factors without needing an area model. 6x plus 1 times 6x minus 1, same idea. 6x times 6x, 6 times 6 is 36. So that'll be a 36x squared. And then 1 times negative 1 is negative 1. So that'll be minus 1. Couple more on here that we'll try. 7x plus 8, 7x minus 8. So 7 times 7 is 49. So that'll be a 49x squared. 8 times negative 8 is negative 64. So that's going to be 49x squared minus 64. Again, it just cuts down on the amount of time that you have to go through solving these problems when you know these shortcuts. They're not critical going forward, but they're very, very helpful. So this last one's kind of tricky because the negative's in a different spot. So it's both plus 1 on both of these, but I have a positive 4 and a negative 4. It's just going to work out the same way. So as long as everything's the same, but one of them has a positive somewhere and one of them has a negative somewhere in the same location, that's where this is going to work. So this will be positive 4 times negative 4. That's going to make negative 16 x squared. And then 1 times 1 is 1. So it's going to be a positive 1. So when the negative's in the front there, that's what will happen. It just switches where the negative is. Okay, so now we're going to look at how we can reverse this process. So how we can use this information to quickly factor when we see a situation like this. See the last page here. So I have these problems here, and I'm using this same pattern, the a squared x squared minus b squared equals ax plus b, ax minus b, to solve these problems. So starting with x squared minus 16, I look and I say, all right, what would x squared be? That would be an x times an x. So if I was to make some factors here, I would know that both of them are going to start with an x. Then I look at this 16. Well, it's a minus, so I know that one is going to be a plus and one is going to be a minus. And then I look at the 16. What times itself would make 16? 4 times 4 makes 16. So it would be 4 times negative 4 makes negative 16. 4 and negative 4, just like that. So you're just really going through and finding the square roots of both parts. As long as it's in this pattern where there's no middle term, it's just an x squared and then a last term there, it's always going to work out like this, which is very convenient. If I had x squared minus 49, that's again going to work out very similarly. We're going to have x times x to make the x squared. So that'll be an x and an x. And then 49, that's going to be a 7 times a negative 7. Just like that. Nine x squared minus 25. So I know that 9x squared, 3x times 3x would make 9x squared. 3 times 3 makes 9. And then x times x makes x squared. And then 25, that would be 5 times 5. So one's going to be positive, one's going to be negative. Just like that. Just a couple more on here, cruising on through. All right, so I have 100x squared. So 100, that would be 10 times 10. And then it's x squared, so it's going to be x times x. 10x times 10x. Then I have negative 1. That's going to be a positive 1 times a negative 1. That. All right, last row here. 81x squared minus 36. 81. The square root of 81 is 9. 9 times 9 makes 81. So that'll be a 9x times a 9x. And then 36, the square root of 36 is 6. 6 times 6 makes 36. All right, one more. And this is kind of like the last one we saw on the previous page where the negative was in the different spot. And so it's going to be just like that. So to make a negative 4x squared, 2 times 2 makes 4. So what we'll do is a negative 2x and a positive 2x. Like this. I could have put the negative on either one. Didn't matter. And then 64, that's positive. So that's just going to be positive 8 times positive 8. Square root of 64 is 8. All right. So that is it for the video today. We are just getting into factoring. What we'll end up doing next time is we'll do box and diamond and grouping and some of the more advanced techniques. This week we were just focusing on pulling out a greatest common factor and looking at some little patterns and shortcuts. All right, so that is the end of the video. I thought it was shorter than 30 minutes, but I guess it wasn't. Oh well. That's it.